So the background on this is work to update the PyRocket Docker image developed by Luis. That image is based on a rocker Docker image for geospatial. And Carl Bettiger and I were working on updating that. And also getting an image that would work a little better with GitHub Codespaces. I took the work I've been doing that Carl and I did together and extended that, and I took it in a little bit different direction. Carl mainly worked on creating the environments in a way that made the image a little smaller. I decided to adopt a different design principle, and so this image has both Python and R. And my goal was that in this image, the Python environment, the Conda environment, would follow the NASA OpenScapes Python image environment. And that image itself follows a Pangeo standard. So the Conda environment, how it's set up, the solver that's installed, in these images, it is mimicking Pangeo. However, the base image is a rocker image. So it's using a rocker verse as the base, and then it has a whole bunch of stuff under that to then create this Pangeo-like Conda environment, and then the tools that you would expect. The goal is that if you use this image and you're familiar with Pangeo or the NASA OpenScapes Python image, it will feel exactly the same to you if you're using the Python side. They're not terribly lightweight. They have a lot of geospatial stuff, and they also have this Conda environment, which adds a lot of size. So they're like 9 GB size. All right.
So did you have to get the Pangeo like environment in there, did you sort of have to recreate some of that in this image then? Because you can't,
Correct.
because you use the
Yep.
rocker as the base, right?
Correct. Yeah. So if you look here, this hopefully will take me to the Docker image. Yeah, there we go. Okay. So this is the, oh, let me tell you also another piece about the design principle. So the design principle is that there is a PyRocket base, and then that has both the Python and R, and then other things are built off that. So the intention is this base is what most other specialized images would be built off of. And this is the one, this base is where that structure is. So I'm going to show you the base. So, so it's built off Rockerverse. And then here is where it is setting up this environment. And this is copied from the NASA OpenScapes Python image. So again, it's intended that it will feel familiar if you had been working in that. All of this is the stuff that's being done to set up so that it mimics the NASA OpenScapes and Pangeo. Down here is where your Mamba Forge is installed. Here is where it's creating that notebook environment. So this is all that stuff that is added, and most of it's copied from the Pangeo.
Awesome.
So, And then if you look at the PyRocket Geospatial, you can see that adds a couple things. First off, this is the environment. I try to keep this up to date with what is being used in the most stable OpenScapes image, Python image. The install R is all the spatial packages. But you can see here what it does is it uses the PyRocket base, and then it uses this install geospatial script. So that's how it's installing things. I learned from Carl to always install my geospatial using that script because otherwise things don't work. And then install.r just has packages, geospatial packages. And then the geospatial, the Python part is coming from environment. Here it is, like I said, it's mimicking the NASA OpenScapes image. Requirements is also coming from the NASA OpenScapes in order to make that familiar. Let's see, any other questions on that? Cool. Okay, so couple things about this that I think are cool. First off is that Carl created a workflow, and because I don't know how to do like the matrix thing, so I just have to keep like copying my workflows. So I don't have that skill to use one workflow and then a matrix of things. Need to learn that. But right now I just make a copy of this, and what it does is whenever there's a push to this folder, it goes ahead and creates my image. I know the NASA OpenScapes image already has this, but it was a new skill for me to be able to do that, so I really like that. It's made it so much easier than building images locally. All right, so the big thing that I worked on most recently is getting the Codespaces part working. So now I have these buttons. I could launch it in Bender or Codespaces, but let's do Codespaces. Create that. It's going to take a moment. The goal with the Codespaces is that I wanted to create the experience to be the same as or very similar to what you experience on the Jupyter Hub. Trying to get that, reduce the things when you're fledging off the OpenScapes Jupyter Hub to reduce the new things that you have to learn. So you're not going to be interacting with this in VS Code, except this first step. It is a big image, so it does take a bit of time to build it. While that's building, let's go back here and kind of show you some things about what these unique things about these Codespaces. So in the dev container, I have the Codespaces, and it just has one file. Actually, I have a script that creates this because it's just a template. It's based on the container images. I do not need to change anything for the images to use them in the Codespace. So just use it there. I do need to change the forwarding port. I discovered that if I use the normal port that I would have used, which was 8888, which is what's in the image, then my RStudio link that I'm going to show you in a moment would not work. through much unhappiness, discovered if I just changed it to that, it did work. The other thing is that, or the thing that makes this work, is I have this post start command that's going to spin up Jupyter Lab. Needed to make sure that port's there. No browser, all this stuff, and this stuff, so it doesn't ask me for a password. And then this post create command is going to create a little button that makes it just a little bit easier to for the user to get to it. When I've created these kind of code spaces before, I had to tell the user, hey, look for this open browser thing, click that, or I had to give them these weird instructions, click on port, go here, roll over, find the little globe. And, if I'm teaching a workshop, that's just awkward. So instead, that little post create thing creates this button, and it auto creates the right link. You can see it's got a funky link name there, and I don't know that ahead of time before I create the code space. And what that code is doing is it's populating the link with the right URL for the code space. And now when I run this, it is forwarding to the port for my Jupyter Lab. And so you see it looks very familiar. And then the user can do that. Takes a little time. But the whole experience is the same as on the Jupyter Hub. So, and if I had clicked the Bender button, it would also be the same. Same thing. It's intended that the experience looks same as when you're on the Jupyter Hub and how you interact with it. Okay, so now I'm going to stop, Steph.